So imagine you're sitting at your kitchen table, right, pen in hand, and you're just staring down this massive, terrifying estimate for a brand new home geothermal heating and cooling system.
Oh, yeah. That's a heavily stressful moment for anyone. It's a huge number.
It's massive. You're about to make one of the most significant infrastructure investments in your property's history.
Hmm.
And in your mind, you're thinking you're buying one unified monolithic machine.
Right, just this one magic box that fixes your house's temperature.
Exactly. You view it as a single system designed to keep your home perfectly comfortable year-round. But there's this central illusion at play here, a kind of, well, almost a magic trick that the HVAC industry really relies on.
I mean, we're so deeply conditioned to purchase home appliances as like singular units.
Right. You don't buy the parts separately.
No, exactly. When you buy a refrigerator, you don't evaluate the compressor on a totally different timeline than the insulated box. You just buy a fridge. And the industry applies that exact same consumer framing to geothermal energy.
And we just accept it. We don't question the underlying components. But that bundled mindset is exactly what we are dismantling in today's deep dive.
Which is so needed, honestly.
It really is. So we're looking at some fascinating notes covering an IGSHPA blog post. That's the International Ground Source Heat Pump Association, for those wondering.
Great organization. They do really solid analytical work.
They do. And this post is titled, "The Value of the Ground Loop Heat Exchanger for Interested Third-Party Owners." So our mission today, based on this, is to completely rewire how you calculate the mental math, the payback periods, and really just the long-term value of your home infrastructure.
Because once you decouple these two assets in your mind, the underground part and the indoor part, the standard financial equation of home energy completely transforms.
It just flips upside down.
It really does. You realize the conventional wisdom around residential HVAC investment is just fundamentally flawed.
To set the stage here, think about the current approach to buying a geothermal system like this. It's the equivalent of buying a house along with all the appliances inside it, right?
Okay, I like this analogy.
And then you evaluate the lifespan of the 100-year concrete foundation on the exact same timeline as a 10-year washing machine sitting in the laundry room.
Which is wild when you say it out loud. You would never assess a concrete foundation's value based on a washing machine's failure rate.
Never. Yet that is the exact default logic applied to geothermal energy every single day.
To understand why that standard math breaks down so severely, we really have to physically separate the hardware in our minds. We need to look closely at what you're actually getting for that huge initial investment.
Let's break it down, starting with asset number one, the ground loop. This is the buried infrastructure.
Right, the stuff you never see.
Exactly. We're talking about a network of high-density polyethylene pipe. And depending on your property, this pipe is either buried horizontally in trenches, maybe 6 feet under your yard, or, if you don't have the space, it's sent vertically in boreholes, plunging like 200 and 300 feet straight down into the earth.
And the primary function of this buried pipe is pure thermal exchange. That's all it does.
Is moving heat around.
Exactly. Below the frost line, the Earth maintains this remarkably stable temperature. It's usually somewhere between 50 and 60 degrees Fahrenheit, depending on, where you live geographically.
Right.
So this polyethylene loop is filled with a mixture of water and antifreeze. And it circulates constantly, absorbing that stable heat in the winter to warm your house. And then in the summer, it rejects the heat from your house back into the earth.
And the crucial detail here regarding this first asset is just its sheer durability. I mean, this material is essentially inert in the soil.
Oh, completely. It doesn't rust, it doesn't corrode.
And it isn't subjected to UV degradation from the sun because, well, it's buried under tons of dirt. The documented service life of a properly installed closed-loop system is 50-plus years.
Yeah, and honestly, the material itself is rated for well over a century. The industry hasn't actually reached the physical end of life for modern polyethylene loop technology yet.
Wait, really? It just hasn't failed yet naturally?
It simply hasn't been in the ground long enough to naturally degrade. I mean, there are systems installed back in the early 1980s that are running today with the exact same thermal efficiency they had on day one.
Wow.
So modeling this as a 50-year asset is a highly, highly conservative baseline.
Okay, let's unpack this. We have this permanent foundation in the yard. Then we look at asset two, which is the indoor heat pump.
The washing machine in your analogy.
Yes, the washing machine. This is the mechanical box sitting in your basement or your utility room. It contains the compressor, the refrigerant circuit, The control boards, the blower motors, all that stuff.
And the sources focus heavily on quality inverter-driven units.
Right. And just to clarify that technology for you, an inverter-driven compressor operates on variable speeds instead of a traditional air conditioner that just, slams on at 100% capacity and then shuts completely off. An inverter ramps up and down smoothly.
It's much like pressing the gas pedal in a car rather than just flipping a switch.
Exactly.
And that variable speed technology drastically reduces the mechanical wear and tear associated with those hard starts and stops. Plus, it provides far superior humidity control and consistent temperatures.
It's an amazing piece of tech. But despite that sophisticated engineering, we cannot escape the fact that it is a mechanical appliance.
Right. It has moving parts, bearings, and refrigerants under really high pressure.
Which means it will eventually fail, period. Even the absolute best inverter-driven units on the market are engineered for a lifespan of roughly 20 to 25 years.
It requires periodic maintenance, filters, checks, and one day it will simply die.
So if these two components have radically different lifespans, like 50-plus years versus 20 years, and completely different failure modes, why on earth is it standard practice to sell them with one price and one warranty conversation?
What's fascinating here is how this bundling obscures the true engineering reality. And it's mostly for the sake of a simplified sales pitch.
Because it's easier to sell.
Exactly. It's much easier for a contractor to sell a unified system to a homeowner than to sit down and walk them through a complex two-part infrastructure investment presentation.
I look at this almost like the wiring in your house. Installing a ground loop is like pulling premium Ethernet cable behind all your drywall.
Oh, that's a good way to look at it.
Right. That cable is the permanent infrastructure. The indoor heat pump is just the Wi-Fi router you plug into the wall. You fully expect to swap out that router every few years as technology improves.
But you don't rip open the drywall to replace the Ethernet cable every time you upgrade your internet speed.
Exactly. You'd be crazy to do that. Yet, by bundling the loop and the heat pump under one warranty and one price tag, contractors force homeowners to put both items on the exact same mental amortization schedule.
You end up judging a 50-year geothermal asset by the 20-year lifespan of the box it happens to be connected to in the basement.
And once we mentally separate the buried infrastructure from the indoor appliance, the traditional payback period math just entirely falls apart.
It completely collapses. Because the standard payback calculation treats the installation of a geothermal system and a conventional HVAC system as comparable assets over a long-term horizon.
Let's walk through a typical example of that flawed math. Say a contractor quotes you $30,000 for a full geothermal installation. And then a conventional setup, your standard outdoor AC condenser unit paired with an indoor gas furnace, is quoted at $15,000.
Right, half the price.
Exactly.
Yeah.
So the typical homeowner looks at that $15,000 premium for the geothermal system, divides it by their projected annual energy savings, and concludes it'll take them 12 or 15 years to, quote-unquote, pay off the difference.
And they view that 12-year mark as the finish line. But we need to zoom out. We need to look at a 40-year ownership horizon to see where this calculation goes completely off the rails.
Let's fast forward to year 20.
Okay, year 20. At that point, the conventional $15,000 system is completely exhausted. The outdoor condenser is dead, the indoor air handler is rusted out, and the line set connecting them is probably totally incompatible with whatever new refrigerant the EPA mandates 2 decades from now.
So you're looking at a total gut job. You have to replace the entire system, indoor and outdoor, which means you're spending another $20,000 in year 2046 money just to get back to zero.
Exactly. Now compare that to the geothermal reality at year 20. The polyethylene ground loop out in the yard, it remains completely untouched.
It's still just sitting there.
Still sitting there, still working perfectly. Yeah. You only need to replace the indoor mechanical box. The contractor simply unhooks the old unit, wheels in the new one, and ties it directly back into the existing loop using the exact same flanges.
There are no backhoes in your yard.
No drilling rigs, no trenching in your meticulously landscaped lawn, nothing.
And the cost of that appliance swap might be, what, $12,000 to $15,000?
Around there, yeah.
So if I'm looking at a 40-year horizon, I'm buying the loop once and the heat pump twice. Why does everyone still do the math as if the ground loop just magically vanishes after 20 years?
Because we genuinely lack the vocabulary to discuss sunk assets in residential HVAC. A sunk asset is a permanent investment that continues to generate value without requiring you to buy it again.
Right.
Once that ground loop is successfully commissioned in the earth, Every subsequent equipment replacement is nothing more than an appliance swap.
It's just plugging in a new router.
Yes. And this dynamic creates a massive hidden financial advantage in the second half of the ownership horizon. The conventional homeowner is facing crippling, full system replacement costs every 2 decades.
While the geothermal owner only replaces the appliance inside.
Precisely.
Here's where it gets really interesting, though. The residential market might be mispricing this, but institutional money and utilities are starting to catch on to the exact math we just discussed.
Institutional investors view risk very differently than a homeowner does. They analyze capitalization rates and long-term asset stability.
They're looking decades ahead.
Always. When they look at a buried polyethylene pipe, they don't see an expensive air conditioning accessory. They see a goldmine of predictable performance.
And the core argument of that IGSHPA blog post really leans into this. Utility companies and third-party investors are exploring the logistics of owning the ground loop completely separately from the building it serves.
Because the ground loop is low-maintenance infrastructure with a degradation curve that stretches out over nearly a century. It represents a highly secure, investable asset class.
Right.
To a pension fund or a utility company, a 50-year asset that just quietly conducts thermal exchange without needing ongoing maintenance is incredibly attractive.
And the mechanics of this model are fascinating. Basically, an investor or a local utility company actually pays the upfront capital to drill the boreholes and install that 50-year loop.
They foot the big bill.
Exactly. They retain ownership of that buried infrastructure, and then they lease access to that thermal energy back to you, the homeowner. This is just like how the utility owns the gas main in the street or the water service line to my house, but I own the furnace and the kitchen sink.
If we connect this to the bigger picture, decoupling the ownership in this manner could completely revolutionize residential affordability.
Oh, absolutely.
I mean, the most significant barrier to geothermal adoption is that massive initial capital outlay. If a third party absorbs the cost of the infrastructure, the homeowner's upfront cost drops precipitously.
You'd only be paying to install the indoor heat pump appliance, which suddenly makes geothermal price competitive with a conventional fossil fuel system right on day one.
Exactly. You trade the massive upfront loop cost for a small, predictable monthly connection fee paid to the utility for accessing the Earth's thermal energy.
It completely democratizes access to the technology. But it entirely depends on the market accepting that the loop and the heat pump are separate entities with totally different financial rules.
Which brings up a whole other set of challenges, especially in the real estate market.
Right. I mean, it makes sense for utilities, and it makes sense for people living in 40-year forever homes. But what does this mean for the average homeowner who moves frequently? This brings us to the infamous 8-year problem.
Ah, yes. The 8-year problem.
The average American homeowner doesn't stay in one place for 40 years. Demographic data shows they sell their house and move every 8 to 12 years.
And if you are only going to live in a house for 8 years, a financial model built around a 40-year amortization schedule or a year 20 appliance swap feels, well, largely irrelevant to your immediate financial goals.
Okay, but let's be real. If I sell in 8 years, an appraiser probably won't know how to value a buried pipe. Does this reframe actually help me, or am I just buying a really expensive gift for the next owner?
Well, there are a couple of defenses here. The first is demographic self-selection.
What does that mean in this context?
Basically, the premium installation cost historically means that the people choosing to put these systems in are generally planning to stay put. They are building custom homes or retrofitting properties they intend to retire in. We don't typically see developers installing high-end geothermal loops in quick turnaround speculative housing.
Okay, so the buyer profile leans heavily toward long-term residency anyway.
Right. But the second defense centers on the nature of the asset itself and how it holds value compared to other home improvements.
Like a kitchen remodel.
Exactly. Think about a high-end kitchen remodel. You might spend $40,000 on custom cabinets and marble countertops. But the minute the project is finished, the depreciation clock starts ticking because design trends change.
In 10 years, that kitchen will look so dated.
Exactly. But a ground loop is permanent infrastructure. It transfers directly with the property, and it's completely immune to stylistic trends. You are leaving a 40-plus-year functional asset behind for the next owner.
But, and this is the huge catch, how does the real estate market translate that functional value into appraised value? Because we are currently experiencing a significant appraisal lag.
The appraisal lag is a very valid concern. Many traditional valuation models lack the capitalization rates to adjust for decoupled geothermal infrastructure.
Because an appraiser walking the property with a clipboard is not going to have a checkbox for a buried invisible pipe.
Hmm.
How does a bank underwrite an asset they literally can't see?
And that's the friction point. The physical asset's efficiency and longevity remain real, but proving that remaining value to a financial institution requires meticulous evidence. You cannot simply gesture to your front lawn and ask a buyer to just, trust you that there's 50 years of value buried down there.
So to retain this resale value, the loop must be meticulously documented at installation. The sources make it clear that the solution to this appraisal gap is a very specific type of paperwork.
Yes. Home buyers need to demand a comprehensive as-built packet from their contractor the literal day the installation is finished.
An as-built packet. What exactly goes into that?
It is essentially the architectural blueprint of your buried asset. It must include a detailed schematic showing the exact routing of the trenches or the precise coordinates of the vertical boreholes, along with their exact depth.
It also needs to document the specific fluid type used, right?
Sure.
And the exact length of the pipe installed, the pressure test results from the commissioning phase, and the exact concentration of the antifreeze mixture.
Yes. The goal is to turn invisible magic into verifiable data that an underwriter can actually use to calculate the remaining lifespan and adjust the home's equity.
So if a seller can't produce this, it's a massive red flag.
Oh, absolutely. If you are purchasing a home that already features a geothermal system and the seller cannot produce this as-built packet, you should consider that a significant liability.
Wow. Even if it's working fine.
It doesn't guarantee the system is failing, but it means you are acquiring a mystery. You have no verifiable baseline to present to an appraiser or, honestly, to a maintenance technician in the future. Securing that documentation folder and storing it permanently with the closing documents of the house is the only way to bridge the appraisal gap.
Okay, so since the loop is the critical permanent asset you're either keeping for 50 years or passing on to the next owner, how do you ensure it actually survives that long? I mean, we should temper the idea of indestructibility, right? Because calling any piece of home infrastructure zero failure usually invites disaster.
It does.
So what actually goes wrong in the real world?
Well, when a ground loop fails prematurely, the root cause is almost never the polyethylene material degrading in the soil. Material failure is statistically negligible.
So it's human error.
Exactly. The failure modes are almost entirely linked to installation errors committed on day one by the contractor.
I was reading about the commissioning process, and it seems like failing to properly purge the air out of the lines is a massive problem.
Oh, it's a system killer.
If a contractor rushes the initial flush and leaves air bubbles trapped inside the loop, it leads to pump cavitation over time. And my understanding is that those trapped bubbles aren't just, harmless pockets of air. As they get pulled through the circulation pump, the sudden changes in pressure cause the bubbles to violently collapse.
Yes, and that microcollapsing is highly destructive.
Wait, really? How does air destroy metal?
The imploding bubbles create localized shock waves, and those shock waves literally pit and chew through the metal impeller of the circulation pump over time.
Oh, wow.
So a rushed commissioning job on day one creates a slow-moving mechanical failure that completely destroys your equipment a decade later.
That's terrifying. Another critical failure point mentioned in the sources involves bad fusion welds.
Yeah.
The contractor has to heat fuse the lengths of plastic pipe together.
Right, they melt them together.
And if those joints aren't melted and bonded perfectly, the expansion and contraction of the pipe over the seasons will eventually cause a leak deep underground.
We also see issues with improper antifreeze concentration. If the mixture is too diluted, the fluid cannot absorb enough heat from the earth.
So what happens then?
Well, during a harsh winter, when the heat pump is pulling maximum thermal energy out of the circulating fluid, the liquid can actually freeze solid at the internal heat exchanger.
Yikes.
Yeah, completely halting the system and potentially cracking the internal plumbing.
So aside from poor installation, the only other major hazard to the loop's longevity is human interference down the line. Like a future homeowner deciding to rent a backhoe to put in a swimming pool, or driving a fence post deep into the ground without consulting the schematics.
Which, again, is why that as-built documentation packet is so vital. You have to know where the pipes are.
Right. So the practical takeaway here for anyone navigating this process is really simple. Never cheap out on the ground loop installation.
Never. There is always a temptation to undersize the loop, maybe drilling one less borehole or shortening the trench just to save a few $1,000s on the initial estimate.
But doing that starves the system, doesn't it?
Completely. An undersized loop struggles to pull enough thermal energy from the Earth. That forces the indoor compressor to run harder and longer to compensate.
So you might save money on day one, but it costs you efficiency and equipment lifespan every single year for decades.
It is a textbook false economy.
If I do everything right, though, properly sized loop, meticulous contractor, perfect fusion welds, what is my day-to-day life actually like with this system? Am I constantly tinkering with it? Checking antifreeze levels?
Not at all. If it's commissioned perfectly, your day-to-day experience is incredibly passive. The loop requires zero active management. It should be completely forgotten about.
Really? Just out of sight, out of mind.
Pretty much. I mean, many of these systems utilize a desuperheater, which is this brilliant secondary feature that captures excess waste heat from the compressor and uses it to warm your domestic hot water tank.
Oh, nice. Free hot water.
Basically, yeah. So that desuperheater might need a minor service call once or twice in 20 years. And obviously, you will eventually need to replace the indoor pump after 15 to 20 years. But the infrastructure buried in the yard, it just sits there and works.
So what does this all mean? Dave, an HVAC professional from Hartzell's in Kingfisher, Oklahoma, summarized this shift perfectly in the source material.
He really nailed the framing.
He did. When he's sitting at the kitchen table with a prospective buyer, he strips away all the marketing noise and tells them plainly, you aren't buying one system. The box in your basement is a 20-year appliance. The pipe in your yard is a 50-year piece of infrastructure.
That framework just cuts through the industry illusions so well. And it's a cognitive tool you can apply far beyond residential HVAC.
Exactly. Whenever you look at major investments, whether in your home, your small business, or even your community, always separate the temporary, replaceable appliances from the permanent infrastructure. Don't allow a salesperson to bundle a 20-year problem with a 50-year solution.
This raises an important question, though, a really profound one about the future of energy infrastructure.
Oh. Where are we going with this?
Well, if we fully embrace the reality that buried ground loops are practically permanent assets with century-long lifespans, we have to consider what happens when we scale that technology beyond the individual homeowner.
Like moving from a single yard to an entire neighborhood.
Yes. Imagine a scenario where large real estate developers or municipal utilities begin pre-installing massive interconnected ground loops in empty subdivisions before a single house is even built.
Wow.
What if they start linking individual home loops together into a massive shared underground thermal grid?
The implications of that are staggering. Instead of your individual yard acting as an isolated thermal battery just for your house, your property becomes connected to your neighbor's property.
Exactly. Your front lawn essentially becomes a node in the neighborhood's public utility network.
Sharing thermal energy across the entire street to balance out the heating and cooling loads of the community. That's incredible.
When the infrastructure is designed to last 100 years, it ceases to be a mere home improvement project. It transitions into municipal infrastructure, carrying the same communal weight as the sewer lines or the electrical grid.
It fundamentally changes your relationship with the ground you live on. You are no longer just buying an air conditioner, you are laying down a generational foundation.
It's a completely different way to look at the world beneath our feet.
Something to keep in mind the next time you look at your lawn. That is all the time we have for this deep dive. Keep questioning the bundles, keep looking for the permanent infrastructure hidden beneath the temporary appliances, and we will catch you on the next one.